Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 18 of the December daily LeetCode challenge and we have an easy question in front of us. It's very easy. It's basically targeting one particular data structure. So after a long time we are having something which is slightly different, okay? Because previously we were having, either on the topic of, the iteration of a, single array or a 2D array, or we were having on the topic of heaps, okay? But in this case we are having slightly different questions. Maybe like this is the point from where a different topic will be started, question a different topic, and this is going to be stack. So this is the first question that we're having on stack. So let us see this question. It can solve it also in a brute force way, since it's easy level, so the constraints are in such a way that you can solve it in a brute force way. But yeah, the data structure which they are targeting, basically which they're expecting you to learn, is going to be stack. Okay, we'll come to that also, but let's see the question first. It's going to be 1475. Find prices with a special discount in a shop. Okay, so as you can see, you are given certain prices and you have to return the discounted prices as your answer. Okay, so let's see the question. You are given an integer array prices where prices of I is the price of the ith item in the shop. Okay, there is a special discount for items in the shop. If you buy the ith item, then you will receive a discount equivalent to prices of j, where j is the minimum index such that j is greater than I and price of j is less than prices of I. Okay, less than equal to prices of I. Otherwise, you will not receive any discount at all. Return an integer array answer where answer y is the final price you will pay for the ith item of the shop considering the special discount. Okay, let's I will share, discuss the example one first, and then we will start to discuss about the approach. Okay, I'll show you both approach and the optimal approach in this question. So just see it. As you can see, this is going to be example one. So these are certain prices and these are going to be, this is going to be the final answer that I will try to do it. Okay, initially see, as similar that whatever is here, I'm writing it here, then I'll slowly make the changes and we'll come to the final answer. Okay, see here, first of all, the number 8. Okay, if you see the number 8, basically we'll have to find which is some, that is we have to find a price which is after 8, that is to the right of 8 and less than 8. Okay, we have to find the first such price which is right of 8 and less than 8. Okay, let us see. After 8, what are the numbers? See, for the first number is 4. Is 4 less than 8? Yes, 4 is less than 8. That means this is going to be the discount for the first price. Okay, so you have to do 8 minus 4. Okay, you have to do 8 minus 4 and we are going to get 4. Okay, so I will change this to 4. Okay, now let's see the next one. Now we are at 4. Now we have to find the discount that will apply to 4. Okay, so after 4, what is the first price? After 4, the price is 6. 6 is not less than 4. Remember that 6 is not less than 4. So we cannot do anything much. So after 6, what is the next one? After 6, it is 2. So since 2 is the first number after 4, which is less than 4, so this is going to be the discount for the price 4. Okay. So what you have to do? You have to do 4 minus 2, which is going to be 2. Okay. So this is going to be 2. Then we are at 6. So what is the next number after 6? It is 2. So 2 is going to be, see, first of all, 2 is less than 6, right? So 2 is going to be the discount for the price 6. Okay. What do you have to do? 6 minus 2, which is 4, you have to do. Okay, fine. Now we're at 2. What is the number after 2? 3. 3 is the only number after 3, 2. Okay, so 3 is not less than 2, so we cannot, that is no discount will be given for this, so it will be written as it is. And always for the last number there will not be any discount, so it will be written as it is. So this is going to be our final discounted prices and that is going to be your answer. Okay, so as you can see, it is matching. So what you have to do, for every price you have to search, that is you have to find the next smallest price. That is, for example, see, you have to, this price is 8, right? You have to find the next price which has a value less than equal to the current price. Okay, for example here 4, that is going to be the discount for this price. Okay, as simple as that. So that is the question. If you see, yeah, there is a special discount for items in the shop. If you buy the ith item, then you will receive a discount equivalent to prices of j, where j is the minimum index such that j is greater than I and prices of j is less than equal to prices of I. Okay, so you'll have to find the minimum index such that the value in that index is less than equal to the current price. Okay, that is going to be a discount. You will have to subtract that discount from the current price. Okay, as simple as that. Maybe that is the reason why they are saying it should be less than equal. Okay, if it's not less than equal to, that means it will be greater, and then if you subtract with the original price, you will get a negative answer. Okay, so since discount cannot be more than the price itself, for that reason they are saying it should be less than equal to this. Okay, as similar as that. So I will not spend much time here because this is easy question. If you have not understood this now, don't worry, I will give the link in the description. Go to the question, see it once, see the example once. I will discuss the first example. There are two more examples, just to go and discuss that. Take a pen and paper, trace it out. It's very simple, thus I'm not spending much time here. Okay, if you see the constraints, these are very much basic constraints. You can solve this using brute force. So first we'll see the brute force solution and then we'll go for the optimal solution. Okay, so what is the brute force solution going to be? First, create the answer. Okay, let me zoom in. Yep. First, okay, yeah, this size is better. First, I have to create the answer. I'm capturing the length of the prices. Then I am starting the iteration. Okay, I'm going from index 0 to n minus 1 first. Okay, for each index, I'm calculating the discount. Okay, now I have to start another loop within the first loop. Okay, this loop will be from I plus 1 till the last. Okay, I plus 1 till n minus 1. Okay, similar like that. Now I'm checking whether each j, remember this is the j, this is the I. Okay, I'm checking whether each j is, whether, see, first of all, whichever j satisfy this particular property, that is going to be the minimum. Why? See, we are starting from the lowest in possible index, okay, which is I plus 1 till the last. Okay, remember that. So I'm just checking which index first satisfies this property. Price of j is less than equal to prices of I. Okay, whichever satisfies that, I'm going to break that itself. Okay, I will not proceed after that. Okay, so that particular price, that is price of j, which satisfies this property, is going to be a discount for prices of I. Okay, simple as that. So what I will do, I will do discount is equal to prices of j. Then, now what is the actual price of this going to be? That is the original price, sale price. It is going to be prices of I minus prices of j. Okay, what is price of j? Price of j is basically stored in discount, remember that. So it is going to be prices of I minus discount, which is going to be the original price for the ith item. Okay, remember the original price is this, but the sale price is going to be prices of I minus discount. Okay, that's why I'm initializing discount with 0. That is, if I do not get any value in this particular loop, then I will subtract 0 here. Okay, similar that. That is, the price will remain the same only. Okay, similar that. That I'm going to abandon my answer. Like, then I have to return the answer as simple as that. Okay, if you see the I've already sent the solution and it got accepted. This took around, I can say, somewhere around 60 milliseconds, I can say. Yeah. Now if you talk about the time complexity of this is kind of a O of n square solution. Why? See, there are two for loops, and yeah, both are going till the end. Okay, as simple as that. So that is the reason why it is going to be around 2 O of n square solution. If you talk about the space complexity, this particular thing will have to include in your answer. This is the answer that we are calculating, and this is going to be offense space. Okay, now once some people will say that okay, you can make the changes in the price array itself so that it will save the space complexity. That is up to you. But again, like, this is not optimization, remember that. That is, you will have to discuss with the interviewer whether you can do that or not. But let me tell you this frankly, this in a live interview will not be considered as optimization. Okay, as simple as that. You can change, if you are changing the given input itself to the answer, that is not a optimization, especially for one D array. Remember that. Okay, because that depends on the requirement of the question. Okay, you have to discuss this with the interviewer whether you can change the process that is the given input itself or not, or otherwise you have to create a new array and store the answer. Okay, something like that. Now coming to the most optimal solution, which is going to be a stack. Okay, so what we are going to do in stack, see here. First of all, I will create a stack, and same. First of all, okay, after stack, I will create an answer array. In the answer array, first of all, as I showed you in the dry run also, okay, initially all the answer will be as same as that of the prices. Okay, simple as that. So what I will do is, all the price as it is will be stored in the answer. Okay, initially. Okay, then I'm again starting the loop. The same in the last solution, but after that things are changing. Now in here, if you see, there is another loop inside the first loop. Okay, full for loop. But here, what we are seeing is there is a while loop. What it is going to check for any element I, what I'm going to check whether the stack has non-zero elements, and if the stack has non-zero elements, then the last element that was inserted in remember, in when we are talking about stack, we only talk, see, the only pop operation that can happen from stack is from the top. Okay, remember that. That is, the last inserted element will be popped first. Okay, as similar as that. Last in, first out. So the last entered last entered element, I'm just going to check, see what is this 0. You will understand this for now, just ignore this part. What I'm doing is, for the last inserted element, I'm just checking whether that is greater than the price of I or not. If it is greater than price of I, that means I will have to pop that out. Okay, what I will do, I will just pop it out. Okay, and then I will store the original price and the index in these variables. Then I will calculate the discount. Okay, what is the discount going to be? Discount is going to be original price minus the current value. Okay, that is the price of I. Okay, the price of I, that I'm going to do, and that I will storing in this particular index of the answer. Okay, as simple as that, as you can see. Okay, then after this whole value, that is, if after removing all the elements which are in the top, which are greater than the current element, after doing that, I will be inserting the current element in the stack. Okay, this is how the single element is going to be looking like in the stack. Okay, it has two parts. What are the two parts? First is going to the price itself, other is going to be its index. Okay, why I need the index? Because as you can see, when I'm popping out, I need the index also to make the changes. Okay, if you okay, let me show you the, okay, yeah, actual implementation here. This output will be making it easy for you. See here, this is going to be your stack. Okay, this is how the stack is going to be, and this is when the things are popped out. I'm printing this description. Okay, simple as that. Let us see first 8 got inputted. Okay, so this is how your stack is looking. Now in the next iteration, 4 is about to be inserted. Okay, before inserting 4, I will just check whether the top of the stack has a greater element. Okay, in this case, yeah, 8 is the element which is greater than 4. Okay, so what I will do, I will pop it out and make change in the answer. Okay, so as you can see, the original price is 8, then the new price is going to be 4, because the discount applied is 4, which is coming from here. Okay, Now this change will be made in the answer array. Okay, the final array that we're returning, it will now be 4. Okay, which is going to be the new price. Okay, fine. Next, this element will be inserted now. Okay, this element 4 will now be inserted, as you can see here. Now comes the third element. Okay, now 6. When I'm inserting 6, the only element that is present is this one. Okay, whether this is greater than 6, no, 4 is not greater than 6. Okay, 4 is not greater than 6. So this also, both of them will be now in the stack. Okay, nothing will be popped out as of now. Okay, the next element is coming is 2. So now when 2 is coming, if you see the top of the stack is going to be 6. Okay, remember, last in first out. Okay, that is the principle of stack. Okay, now the 6 is going to be greater than 2. Okay, so what is the discount going to be? Discount now will be 2, and the original price was 6, so the new price will be 4. Okay, as simple as that. Now this will be popped out. Okay, this particular thing got popped out. The next, now the topmost element is this one, 4. Whether 4 is also greater than 2? Yes, 4 is also greater than 2. So what is the new price going to be? The original price is 4, the discount applied is 2, so the new price is going to be again 2. Okay, if you can see here, these are the ones. Okay, 4, then 2 and 4. Okay, as you can see, 2 and 4. So 2 came from here, 4 came from here. Okay, as simple as that. But remember one thing, if you see here, that order is changing. Okay, here I'm writing 4 first, then I'm writing 2. Why? That is the reason why. Basically, see, the idea here is the this value will be written first in the answer, then this value will be written in the answer. Okay, but yeah, the order is different here. Okay, that is the reason why we'll have to also store the index in the stack. Okay, that is, for each element we are also storing the index for this reason only, because in a stack, what will happen is, the way the elements are present in the same order will not be making the change in the answer. Okay, the order in which we will making the change in the answer depends on the how much big they are, or how many elements are bigger than them, and all that factor. Okay, for that reason we're also storing the index. Remember that part. Okay, now comes the 2. Okay, after, see, 4 and 6 will be popped out. Okay, then 2 will be inserted. Okay, at last you see this is going to the element 2. This is only element in the stack now. Okay, now comes the last element, which is 3. While inserting 3, I will check whether the top element is greater than 3 or not. In this case, 2 is not greater than 3. Okay, so 2 will also remain, and 3 will also remain. Okay, and then the loop will be over. Now what that means, that means for these two elements there will not be any change. Okay, they will remain as it is. For the first three elements there were changes, that is, there was a discount applied, and for that reason the prices got reduced. Okay, if you see the code, basically, if you, yeah, so for each element I'm just checking whether the stack has non-zero elements, and if it has non-zero elements, the last inserted element, whether it is greater than or equal to price of I or not. Okay, if it is greater than or equal to price of I, that means I got element to be popped. So what I'll do, I will just pop it out. Okay, then since a stack has six stack element has two parts. Okay, the first part is the number itself, that is the price, and the other part is the index. Okay, so that is how I'm receiving them. Okay, original price and index. What I'm going to do, I'm going to original price minus the discount. Okay, what is the discount? Discount is going to be this. Okay, as simple as that. This will be now stored in index. Okay, from where index is coming? From here. Okay, in the answer of index I'm going to store that. Okay, this will keep continuing till there is a single element in the stack and that is going to be greater than the current price. Okay, till then it will continue. Once I come out of that, I will insert the current element. Okay, that is prices of I comma I. Okay, I is the index. Remember that it will be inserted. And remember one part, remember answer and see, when we are at this point in the code. Okay, this and this are exactly same. Okay, all are having same values. For that reason, only ones which are having a discount will be changed, otherwise it will remain as it is. Okay, remember that part. So once we are coming out of the while loop, we are writing the answer. Now you will ask me what is the time considered to this, and you will say that, see here also there is a for loop and here also there is a while loop. Then how you can say that this is going to be slightly better solution? Because see, here also we have same thing. Okay, there was a for loop here, there was a for loop here, and we claim that it is going to go n square. Now see the discussion here. See, you have to see it in a different way now. Try to understand this fact. This particular loop, it is open. I agree with that. Fine. Now instead of discussing the code here, what I will discuss now with you is, see, consider the stack. Each element is going to be inserted in the stack only once. Each element is popped out of the stack only once. Okay, both insertion and popping out are a constant operation. That's a constant time operation. Okay, each element will be inserted at most once, each element will be popped out at most once. Okay, as simple as that. So if you see n elements are there, each of them will be pushed at most once, each of them will pop out at most once. Okay, for that reason it is again going to be open solution. Okay, because the time it's going to take for all the elements to be pushed and pushed out is going to O of n again. Okay, for that reason this loop is going to take O of n time, and all the stack operations, okay, for each of the elements, if you take them together, it is again going to take O of n time. Okay, that is why the time complexity is going to O of n. Space complexity still doesn't change, because see here there are two things here. One is going to be answer, and the other is going to be the stack. Okay, in the worst case, stack is also going to have n elements. Okay, so still considering both of them, okay, this is again going to be O of n only. Okay, simple as that. This is same as the previous one, but yeah, but literally saying that, yeah, in this case we are only having one array. Here we are having two arrays basically. One is for the answer, other is for the stack. In the worst case, stack will also have n elements. Okay, remember that part. So yeah, in the worst case, it's still a little off and only, but yeah, if we are checking the space complexity in real time, you will get to know that in the worst case, this particular space complexity will be slightly higher compared to the initial solution. Okay, but yeah, but that could be compensated in terms of time complexity. It is going to take off and square, which is very very worse compared to the one here. Okay, so at the slight cost of space complexity, though it is not in terms of, remember, of that is bigger notation. In the bigger notation, both are same. But yeah, if you are actually calculating like how many MBs and all it is going to consume, you will see the difference that, yeah, because with slight, heavy space complexity, slightly heavy space consumption, we are able to improve the time complexity. Okay, simple as that. That's what I will say. So yeah, friend, that was all for today. See, remember, both of them are going SF OFN only, it will be, and this is also OFN only. But still, if it is OFN, if you compare this with that is going to consume, it will be slightly higher in some of the cases compared to the first solution. But still, we are paying that price. We are actually paying that price for getting a better time complexity, which is worth it. Okay, as simple as that. So at the cost of the space complexity, we are improving the time complexity. That is the summary of here. So we saw this stack question for the first time in December daily code challenge till now. Maybe like upcoming questions we are also going to on stack. So yep, we'll see the next questions tomorrow. And if you like my video, if you learn anything new from my video, please do subscribe to my channel. It really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.